Hi. Today we're going to be talking about extraneous solutions, an interesting part of algebra. So let's say you're solving an equation and you get your solutions. Let's say you get two solutions. Now some solutions can be extraneous. That is, you take it, you put it back into the original equation, and you get an answer different than what you would expect. Both sides of the equation aren't equal. It doesn't appear to be a solution. We call that extraneous. Now, if you're listening to this and you hear, well, if it's a solution, doesn't it have to work? What do you mean both sides aren't equal? That doesn't make any sense. Well, here we'll go over what extraneous solutions are, when you have to worry about them, and when they occur in algebra problems. Extraneous solutions are very, very important to deal with. Sometimes you can solve a problem completely right, but if you include an extraneous solution, you can get the problem wrong in assignments, quizzes, and tests. So we'll go over how to deal with that and strategies for working with extraneous solutions. So, let's say I'm solving an algebra problem like this. The square root of 5x minus 4 equals x minus 2. And I'm using this problem not to, say, oh, this is what algebra problems usually look like, but to give an example of where extraneous solutions may come up. So let's say I solve this problem. I want to square both sides. So I cancel out that square root. Just get 5x minus 4. And I get x minus 2 squared. I'll expand that out. And I get x squared minus 4x plus 4 on that side. I want to get all my terms on this side so I can factor this quadratic. So I'll get x squared minus 9x plus 8. I want to factor this, so I'm looking for two numbers that multiply together to get 8, but add together to get negative 9. So I'm thinking negative 1 and negative 8. So I have 0 equals x minus 1 times x minus 8. Either of these can be 0. I have x minus 1 equals 0 and x minus 8 equals 0. So x equals 1 and x equals 8. Right? So there we've solved a pretty complicated algebra problem. We've gotten our solutions and we want to think, oh, we're done. I solved this problem. I have my solutions. That's all I have to worry about. Unfortunately, not. Let's say I want to test these solutions, right? I really want to know that I've solved my problem right. The obvious thing to do would be to take these values and plug them back into the original equation. When we do so, we would expect, hey, this side is going to equal this side if this is a solution for x. If x equals 8, then these sides should be equal. So let's test that. 8 times 5 is 40, so I have the square root of 40 minus 4 equals 8 minus 2, which is 6. 40 minus 4 is 36, which is indeed 6. 6 equals 6. All right, looks valid enough. I plug my my solution back into the original equation, and I get both sides as equal, so I know that must be the solution. So far, no extraneous solutions, no weirdness. When I plug in x equals 1, something interesting happens. So 1 times 5 is just 5. So 5 minus 4 equals 1 minus 2. I get the square root of 1 equals negative 1. So I get 1 equals negative 1. We can clearly say, hey, 1 does not equal negative 1. This is not a solution. But we solved the equation and got this as a solution. That's really weird. This is what we call an extraneous solution. A solution that you get when you solve these equations algebraically. When you take them and plug them back into the original equation, you get something really, really weird. You get it where both sides aren't equal, and it doesn't appear to be a solution. That's what an extraneous solution is. Now, when do these extraneous solutions occur? Am I going to have to check every algebra problem for extraneous solutions? No. There are certain things that occur in different types of algebra problems that cause there to be, or at least make it likely for there to be extraneous solutions. We'll go over what they are. The absolute biggest thing that causes there to be extraneous solutions is squaring. And at first, that might seem kind of weird. Like, if I square a number, I I'm just gonna get that number squared. I'm not gonna get a whole different value. I'm not gonna morph my value into something completely different where, you know, it's no longer a solution. But let's think, right? Say I have x squared equals y squared. Does that mean x equals y? No. This is a very big thing to remember. If I say x equals -2 and y equals 2, well, the -2 squared is equal to 2 squared, but -2 is not equal to 2. So when I square a number, I'm not always able to reverse it. So if I'm solving an algebra problem, in an algebra problem I happen to be squaring, or, you know, kind of the opposite, taking the square root, I am not going to be able to infinitely reverse the process. I'm not going to be able to take, you know, x squared and just have it be x and have it still work in this equation, right? And when we don't have that reversibility, we have extraneous solutions, or at least we have to worry about extraneous solutions. So in the previous problem, we were taking the square root. That process is not always reversible, so we have to watch for extraneous solutions. And you might say, reversibility, what does that mean? Well, that just basically means if I were to take this and take the square roots, I would have this, right? But this in this case isn't true. If I take the square roots of both sides, I get something that absolutely is not true. -2 does not equal 2. And when I don't have that reversibility, when I can't do an opposite operation, then I have to worry about extraneous solutions, where the two sides are no longer equal. They're no longer balanced and equal. Another case where you have to worry about extraneous solutions is when you're multiplying both sides by some variable, right? Let's say I have ax equals ay. Does that mean x equals y? Once again, it doesn't necessarily mean that. If a equals 0, right, I'll have 0x equals 0y, since 0 equals 0. So anything multiplied by itself equals 0. But if x or y were, you know, 2 or 3, x does not equal y. It's not a solution, right? So when I'm multiplying or dividing by certain values on both sides of an equation, I also have to worry about extraneous solutions. So the big case is squaring, or taking the square root or squaring, and multiplying or dividing. That's where I have to worry about extraneous solutions, and that's why I have to always be careful. Take the values I find and plug them back into the original equation to see that they both cause both sides to be equal when I plug them back in. And if they don't, they're extraneous, and I should not include them. So if you follow that process, you will always find the right solutions. You won't have to worry about getting marked wrong for finding an extraneous solution. That's it. I hope you enjoyed, and I hope you have a great day.